into two projects. In this video, we are going to explain about the project that is machine learning and deep learning techniques for distributed denial of service anomaly detection in software defined networks, that is current research solutions. Before getting into the execution, first let us understand what is the project about. So, software defined networks that we call in short as SDNs have completely changed how we manage and control networks. Before SDNs, networks were more rigid and hardware focused. But with SDNs, everything becomes flexible. This flexibility allows network administrators to have more control over how traffic flows through the network. They can program and adjust the network on the fly, which makes it more efficient and adaptable to the needs of the users. However, with this newfound flexibility, there is a downside too. SDNs are more vulnerable to attacks, especially distributed denial of service, that is DDoS attacks. These kinds of attacks are designed to overwhelm and crash a network by flooding it with massive amount of traffic, which can bring everything to a halt. The result is serious issues like network downtime, loss of data, and even damage to organizations' reputation. And with the way cyber attacks are evolving these days, especially as attackers are getting more clever, detecting and dealing with these threats has become much harder. So the frequency of DDoS attacks is skyrocketing. That is, it is increasing, and the scale of these attacks is growing rapidly. In fact, reports suggest that the number of DDoS incidents went from 7.9 million to that is million in 2018 to an expected range of 15.4 million in the future. That's a massive increase, which means these attacks are becoming more common and potentially they are damaging. So the problem we are facing is that security measures that we have relied on in the past aren't keeping up with these new threats as new networks that is as networks becoming more complex and attackers are getting more sophisticated. Traditional defense methods just can't handle the scale or evolving nature of these DDoS attacks. What this really means is that we need better, faster, and more automated ways to detect and stop these attacks before they can cause any serious harm. So, the urgency for developing more effective detection and mitigation strategies is clear. The solution we have right now are falling short, and they are not able to keep up with the new, more advanced techniques attackers are using. So, it is becoming critical for us to come up with smarter and more automated ways to protect networks and prevent these increasingly complex and damaging attacks. So, to overcome with all these issues, this project is all about creating a smart, automated system to detect and handle distributed denial of service attacks in software defined networks. To do this, this project incorporates multiple models that are machine learning and deep learning models to address these vulnerabilities and improve how we protect the SDNs. So, the goal of this project is to use more advanced approaches like supervised and ensemble solutions, which are RNN, that is recurrent neural network, LSTM, that is long short term memory, GRU, which is gated recurrent unit, bi-LSTM, that is bidirectional long short term memory, CNN is convolutional neural network, and CNN with bi-LSTM, which is the hybrid model. So these are the deep learning models incorporated to attack classification. Then these are the machine learning models, which are support vector machine, random forest, ADA boost, XGBoost, decision tree, logistic regression, and KNN. So these are the set of models used in this project to classify the attacks. And and what the system will do is it will analyze the flow of the data across the network, build profiles of what normal traffic looks like, and then spot any suspicious activity that may indicate DDoS attack. Once the attack is detected, so the aim is to make the detection process more accurate and quicker, thus minimizing the impact of increasing number of DDoS attacks on modern networks. So this is all about the proposed system. Now let's move on to the extension part. So to further improve the accuracy, we have incorporated an ensemble model, that is voting classifier, which combines the predictions from multiple models to make a final prediction. So the idea behind this is different models have different strengths, and by combining them, we can create more robust and accurate prediction. The method takes the output from each individual model and aggregates them, improving the overall performance of the system. And we have also developed the front end using Flash framework. So this front end allows for easy testing by users and provides a clear and intuitive way for them to interact with the system to ensure that only authorized users can access the system. And we have incorporated user authentication mechanism too, which adds an extra layer of security to protect sensitive data and maintain control over who can use the system. And moving on to the implementation, to implement this project, we have followed set of steps. So let's understand what the steps that we have followed. So first, we have imported all the necessary libraries and packages that will help us to perform data analysis, machine learning, and build the interface. So this includes libraries like Pandas, scikit-learn, Flask, and others. Then comes exploratory data analysis part. So next we explore the data set to understand its structure, check for missing values, and get a general sense of the data. This helps us to plan how to process and clean it. Then comes data pre-processing. So here we go through the data to remove any duplicate that could affect the model performance. Then we have drop cleaning. So here the step involves removing any irrelevant or unnecessary columns from the data set that won't add value to the model. Coming to the data visualization, at this point, we visualize the data using graphs and charts to better understand the relationship between features and identify any patterns or trends that might help us later in modeling process. Then comes label encoding. So here, machine learning models, since machine learning models often work with numerical data, we use label encoder to convert categorical features into numerical ones, making it easier for models to process. Then comes feature selection. We select the important features, that is the most important features in the data set. So we use technique called select percentile to choose the top features for that are most relevant for the prediction. And then we split the data into train and test sets. Train set is used to train the model, and validation set is used to evaluate how the model performs. Then comes building the model. So here we initialize and define all the layers of the model. After defining, we train it with a training data set. This is where the model learns patterns in the data to predict the attacks. Then comes evaluation. So we evaluate all the models using accuracy, precision, recall, and FN score, and we compare all of them through the graphs. Then comes the part of front end. So at this point, we build a user-friendly front end using Flask, which allows users to interact with the system. The front end also includes a registration and login feature for user authentication supported by an SQLite database. And then comes user gives inputs as feature values. So here in the front end users, they will be giving inputs related to attack. And then it will be pre-processed at the back end. It will be fed with the train model. Finally, outcome will be displayed to the front end of the application. And coming to the algorithms used, these are the algorithms used in this project to train the model. So here we will be using all of these models to train the data set to predict the attacks. And to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, we need to open the code folder that contains source code files. So let's open the code folder of the project. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So this is the archive folder in which we have data set. So this is the data set that is used in this project to train the models for detecting the attacks. And here in the static folder, we have files related to CSS, JavaScript, and Bootstrap 4, which are important for the visual appeal. And here in the templates folder, we have HTML files that are used in this project. It includes index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the model file in which algorithm information is stored, and this will be loaded into the project code during runtime of the application. And this is the notebook file. This is the Jupyter notebook file, which contains combination of code, graphs, and outputs all in one place. So it allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the sample file in which we have test cases that we will be using in the front end for prediction purpose to test it. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open Anaconda prompt. It is open. Give the command cd, give the space, and paste the copied path. Now click on enter. So here you can observe that current directory is changed to the code folder's path. So now compile app.py file by giving the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. This is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project which is displayed in the browser, and this is developed using Flask framework. Now we need to get signed up. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly log in. Click on login. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see parameters, right? These are the parameters need to be given as the input. Based on the given parameters, we will be getting the prediction. So let's understand each of them. How will they be used in this project? The first one we have is the source IP, that is SRC IP. This refers to the IP address to the device, that is of the device or a machine that is sending the data. Then we have source port. It is the source port is the communication endpoint used by the sender to send the data. It is part of the source device network layer. Then we have destination IP. So this is the IP address of the device or machine that is receiving the data. And then we have destination port. So this is the destination port. It is a communication endpoint of on the receiving device. It specifies which service application the data is intended for for on the destination machine. Then we have timestamp. So it is a timestamp indicates the exact time when a particular packet or a data flow was recorded in the network. This helps in analyzing the time and duration of the flow. Then we have flow duration. This is the total time for which a particular data flows last from start of the connection to the end. And then we have flow packets, that is packets per second. So this is the rate at which packets are sent during the flow. It shows how many packets are transmitted per second. Then we have flow IET mean, that is the inter-arrival time. This is the average time between consecutive packets within the flow. A smaller value indicates high-speed transmission. Then we have flow IIT standard deviation. This measures the variability or spread of the inter-arrival times of the packets. High variation can indicate irregular traffic patterns. Then we have flow IET max. So it is the maximum time between any two consecutive packets in the flow. Then we have flow IET min. It is the minimum time between any two consecutive packets in the flow. It helps to identify instances of very fast or regular packet transmission. Then we have flow IET total. It is the total inter-arrival time. It is the sum of all the inter-arrival time across all the packets in the flow. Then we have flow IET mean. It is the forward inter-arrival time mean. It is the average time between packets in the forward direction of the flow. It is similar to flow IET mean. Then we have forward IET max. It is the forward inter-arrival time maximum. So it is a maximum inter-arrival time between packets in the forward direction. Then we have forward header length. So this indicates the length of the headers of the packet sent in the forward direction of the data flow. It provides information about the overhead of the packets. Then we have forward packets. It is the rate of the packet transmission in the forward direction of the flow, that is how many packets are sent per second. Then we have subflow forward packets. These are the number of packets in the subflow, specifically in the forward direction of the data flow. This helps to understand the volume of traffic in that direction. So this is all about the parameters. Now let us enter them. So let's open the sample file for that, in which we have test cases. So in this file, we have the test cases. So these are the different test cases that we will be entering now. So let's enter them. Here, let's apply filter to the target label. So let's apply filter and let's apply filter to the class 0 and now click on OK. So these are the values to be entered. Let's enter the first input, that is the first test case, where source IP is 20479 and SRC port is 0. Destination IP is 4374. Destination port is also 0. And then we have timestamp, that is 3324. Give it. And then flow duration. So the flow duration value is some number. And here we have flow packets per second. So let's enter them. is 5.03, and then we have flow IIT mean. Let's enter. And then we have flow IIT standard deviation. So flow IIT standard deviation here we have entered, that is 9712. And then we have flow IIT max. So here we are entering flow IIT max. And then we have flow IIT min. So let's enter that. And then we have flow IIT total, that is 11989795.677. And then we have flow IIT mean. And then we have forward IIT max, that is 203046.566. And then we have forward header length. So let's give that. Forward packets is 5.03. And then we have subflow forward packets. Copy it, paste it. So I have entered all the inputs. Now let's click on predict. So this given input, it will be pre-processed at the backend, and then train model will be giving us a prediction. So here we got the prediction that there is an attack detected and the attack type is botnet attack. So here botnet attack has been detected. Let's apply a filter to the class 1. Click on OK. So click on prediction. Let's try with this case where source port, that is source IP is 58. Port number is 46520, and then destination IP is 532. Destination port is 462.691472. Timestamp is 4047. Flow duration is 5. Flow packets per second is 40,000. Sorry, that is 4 lakhs. And then flow IIT mean is 5. Flow IIT standard deviation is 0. And then flow IIT max is also 5. Min is also 5. Flow IIT total is 0. And the next values we have as next two values are also 0. So let's enter them. And then 24 is the forward header length. Then forward packets are 2 lakh. And then subflow forward bytes, that is forward packets are 1. Now click on predict. So here we got the prediction that there is an attack detected and that attack type is brute force attack. So here you can observe that brute force attack has been detected. Now let's apply filter to the class 2. Click on OK. Click on prediction. So now let's try with this case. So where source IP is 16263, source port is 0, destination IP is 2866, destination port is 0, timestamp is 3420, flow duration is 4, flow packets are 4, flow IIT mean is 12500 and 00, and then we have flow IIT standard deviation is 1. If you have entered some value wrong, so let's recheck again. Source IP is correct, then the source port is also correct. Destination IP is correct. Destination port is correct. Timestamp value is also correct. Then flow duration is correct. And then here flow packets are 1,25,000. And then flow IIT mean is 1. And this is the standard deviation. So copy the value, that is 0.81. And then we have next values as, sorry, something has happened, just wait. Yeah. So now let's enter them again. So here, let's continue. So here the forward, that is flow IIT marks as 2. And the next value is 0. Flow IIT total is 4. The next value is 1. IIT max is 2. 0. 1,25,000. So that is 12,50,000. And then we have subflow bytes as 5. Now click on predict. So here we got the prediction that there is an attack detected and that attack type is DDoS attack. So your DDoS attack has been detected. Now let's apply filter to the class 3. Let's enter the values. So let's enter this case. So I have entered all the parameters. I've entered all the parameters. So now let's click on predict. So here we got the prediction that there is an attack detected and that attack type is malware attack. So here you can observe that malware attack has been detected. Now let's apply filter to the class 4. So apply filter and now let's enter. So let's enter this case. Click on prediction. So I have entered all the parameters. Now let us click on predict. So here we got the prediction that there is no attack detected. It is normal. So here in this case, attack is not there. There is no attack. It is normal. Now let's check with the last class, that is class 5. Let's apply filter to that. So these are the test cases that we're supposed to enter. Click on prediction. So I have entered all the inputs here. Now let's click on predict. So here we got the prediction that there is an attack detected and it is attack type is web attack. So here web attack has been detected. So this is how you need to execute. Now let's check with the graphs. Click on graph. So the first graph which we have is a sample outcome graph. This shows the class distribution of the target class. Here on x-axis we have all the attacks and on y-axis we have count of each attack. And this is the correlation matrix. And this is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained for classifying the attacks. And this is the precision score. This is recall score. This is FN score. Now click on sign out. In this switches, by giving input to the application based on the given input, it will predict whether there is an attack or not. If there is attack, it will detect which type of attack it is. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.